Okay, so let's say that I wanted to find the antiderivative of x e to the x dx. Now, in order to do this, I need something called integration by parts. So integration by parts. Now, when I first look at this, I try to think about if I can use something like u substitution or the reverse power rule, but I really can't because you can't really use that to simplify this any further to find the antiderivative. So I need to use something else, and that's integration by parts. And the integration by parts formula is as follows. So notice that I tried to slow down when I wrote the v's because sometimes I get confused with the u's and the v's. They look very, very similar. So that's one thing that I don't like about this formula, but you'll get used to it once you write the u's and the v's a lot to try to make them more pointy. So here we need to apply this formula, but before we can, we need to identify what the u and the dv is going to be equal to. So the u is going to be equal to, in this case, x. So du is going to be equal to 1 dx, or just dx. Now, how did I choose my u here? For choosing the u, I have, well, we typically use an acronym. So the acronym is as follows. We can use the acronym Li8. So this is the way we can use it. So L is going to be standing for logs, I for inverse trig, A for algebraic stuff like, x to the power of 2, something like that. So algebraic stuff, I spelled that wrong. Okay, T for trig stuff, and E for exponential stuff like e to the x, e to the 2x, stuff like that. Okay, so this is my Li8 acronym. So I can use this. So based on this, we have algebraic stuff before exponential stuff. So that's what I'm going to set equal to u. Next, we need to look at dv. dv is just equal to whatever's left over. That's just e to the x dx. I want to find v, so I'm going to find the antiderivative of this business here. And that's just equal to e to the x plus c, which we don't need because that plus c is not going to be useful. And notice that we have everything that we need, so we can plug it into the integration by parts formula. We have the u, we have the dv, we have the v, and we have the du. So again, the integration by parts formula is really powerful, but the integration by parts formula comes from the product rule. So that's one thing that is good to know. Okay, so now that we know all this stuff, we can now use it in the formula. So this is just going to be equal to, let me do this in blue. We can plug in the u, so that's just x. dv is e to the x dx. So this is x times e to the x dx. This is going to be equal to, what is this going to be equal to? So uv minus this stuff. So what is u? U is just x multiplied by v, which is e to the x, minus the antiderivative of e to the x du, which is dx. So this is just what we have here. And this is actually going to simplify quite easily. So it's just x e to the x minus, this is just e to the x. And then remember, we have to add the constant of integration. That's the plus c at the end. And maybe I can do that in a different color just to kind of show you that you need to add it. It's very important because you are finding an antiderivative. And so this is your answer. Now, if I take the derivative of this, I should get x e to the x. Is that the case? Let's see. So if I find the derivative of this, I can find the derivative of each part separately. So x, we have the product rule here, so we can use the product rule. So this is the d by dx of x e to the x. This is going to be equal to 1 times e to the x plus x times e to the x, which is equal to e to the x plus x times e to the x. Okay, and then this stuff here is just minus e to the x. So minus e to the x, the e to the x and negative e to the x, they just get canceled out. And I should probably specify here that I'm doing minus the derivative of e to the x. So that's just minus the derivative of e to the x, and I have little space, and that's just equal to x e to the x, which is what we have over here. So the integration by parts formula worked beautifully. I will be doing more examples in future videos. Hope you found this video helpful.